mantra in physics and chemistry, where you have a lot of math calculations. Common mantra is, if the units are right, the answer is right. And that's kind of on that angular velocity thing. If units are right, the answer is probably right. Of course, barring arithmetic mistakes, which we all can do. Okay, first one we want to graph. Y equals 3 times the cosine of 2x times pi over 3 plus 2. So we always identify the amplitude, period, phase shift, and the translation. Amplitude is the leading coefficient. Period for cosine and sine, secant and cosecant is 2 pi divided by the leading coefficient. 2 pi divided by 2 is pi. The phase shift is the value of x that makes this behave like 0. Twice pi over 6 is pi over 3 minus pi over 3, so that's pi over 6. And the translation is tacked on at the end. So our graph frame, the center line is the translation. The amplitude up from there, down from there. Left-hand side is the phase shift. Right-hand side is the phase shift plus the period. And within the graph frame, we sketch a cosine curve. Starts out horizontal and ends up horizontal. At the quarter points, it crosses the axis. That's a reasonable sketch with all the labeling. Number 2, 3/4 of the tangent of x over 2 minus 10 degrees, x over 2 minus 10 degrees minus 2/3. So, amplitude 3/4. Period. The standard for tangent and cotangent is only 180 degrees, or pi. In this case, degrees. So 180 divided by 1/2 is 360 degrees. Phase shift, 20 degrees divided by 2 is 10, minus 10 is 0. And translation, negative 2/3. So our graph frame, the center line is the translation, negative 2/3, for negative 8/12 plus 9/12 is positive 1/12. Our negative 8/12 minus 9/12 is negative 17/12. Starting at the phase shift and going that far to the right. And this is a tangent function, which will be asymptotic. Halfway through. Begins and ends at the center line. Goes through the quarter points and the boundaries. Is a sweeping curve upward and a sweeping curve downward through the quarter points. And number 3, 1/2 the cosecant of x over 3 plus 20 degrees minus 1/3. Amplitude, half. Period, Standard is 2 pi. 2 pi divided by 1/3 is 6 pi. Let's see, negative 60 divided by 3 is negative 20. So the phase shift is negative 60. And the translation is negative 1/3. So negative 1/3. Half up from there is positive 1/6. Half down from there is negative 5/6. Left-hand side is negative 60. Oh, this is in degrees. Let me change this. 360 divided by 1/3 is 1080. 1080 minus 60 leaves 1020. Okay, the cosecant is the reciprocal of the sine. Sine, max it out at the quarter point. So, cosecant for u there, and a for u there. That is half a period each. Those are graphs. Verify the following identity. 1 minus cosine x or sine x, and the claim is equal to sine x over 1 plus cosine x, I think is the claim. I choose to multiply this side by 1 plus cosine x over 1 plus cosine x. I get 1 minus cosine squared x over 1 plus cosine x times sine x. This is sine squared x over 1 plus cosine x times sine x. One of the sine x's divides out, leaving sine x over 1 plus cosine x. Numbers 5 and 6. Given sine of alpha is 7/25, and it's in the first quadrant. And cosine of beta is -3/5, and it's in the second quadrant. Find the exact value of some sum and difference in double angle and half angle formulas. So let's see. Sine alpha is 7/25. Cosine alpha is 24/25. Tangent of alpha is 7/24. Beta, let's see. The cosine of beta was given as -3/5. It's in the second quadrant. So the sine of beta is +4/5. And the tangent of beta is -4/3. From the Pythagorean relationships, first off, sine of alpha plus beta, sine of alpha plus beta, sine alpha cosine beta, plus cosine alpha sine beta. Placing these values in, 7/25, -3/5, plus 24/25, sine beta, what was it, 4/5. Denominator is 125. Let's see, 4 times 24 is 96, minus 21 is 65.
The summer differences.
75. And that does reduce, interesting, 3/5. Number B, cosine of alpha minus beta.
And did you reduce it by 25s on that one? Yeah, 25. Okay, just want to make sure.
I did that right.
Okay.
Okay. Cosine alpha minus beta is cosine alpha, cosine beta, plus sine alpha sine beta, which is, let's see, 4/25 times negative 3/5 plus 7/25 times 4/5, negative 72 plus 28. That 8 from 12 is 4, 2 from 6 is 4. Oh, okay. 44 over 125. Number 6, the same problems. We'll give a tangent of alpha over 2
Gonna be one of these stars.
and tangent alpha over 2
Half angles.
has several options. Square root of 1 minus cosine alpha over 1 plus cosine alpha, but this can be 1 minus cosine alpha over sine, or it's sine over 1 plus cosine. Okay, you can pick any one of those. I think I'll pick this one, just because. And we have 25/25, which is 1 minus 24/25 over sine alpha, which was 7 over 25. Multiply by 25 over 25, we'll get 1 over 7. And the last one, cosine of 2 beta.
This is in this thing right here. To find those.
Cosine of twice beta. 3 choices. Cosine squared beta minus sine squared beta, or 1 minus 2 sine squared beta, or 2 cosine squared beta minus 1. Let's use the last one. Twice, negative 3/5 squared. 9/25 times 2, 18/25. 18/25, subtract 25/25 is negative 7/25. Okay, and page 2, find the exact values of the inverses.
No.
Sine of the inverse tangent of 20 over 21. That means I have a triangle. Sides 20 over 21 is my angle, and the sine of that angle is the hypotenuse, which I believe is 29.
Do the height.
And number 7b, the inverse sine of the cosine of 7 pi over 6. Cosine of 7 pi over 6 is minus square root 3 over 2. And the inverse sine of that is minus pi over 3. And if you put it in your calculator in degrees, it'd say minus 60 degrees if you did it in your calculator. Okay. Which gives us, find all the solutions for a quadratic in sines, and then solve a couple of triangles. So we're already 5 minutes past time.
So keep going.
Well, that's.
If everybody wants to leave, they can get out and go.
Good grade.
I know. That's why we're
Yep.
here.
My kids can
So,
wait.
That's right. I don't want to come back.
5 sine squared x plus 3 sine x minus 2 equals 0. This factors is 5 sine x, 2 sine x, 1.
This one.
Okay, so sine of x is equal to 2/5, or the sine of x equals -1. This says x is 270 degrees. Does it say radians or? Oh, okay. 3 pi over 2. Okay, and this one we have to use our calculator for. 2 pi over sine. Okay. Shift inverse sine, on helps. Shift inverse sine of 2 divided by 5, close, times pi, because this is in radians, divided by 180, and all that gives me 0.4115, so, or x equals 0.41151684661, or x is equal to pi minus this value, which is pi minus that, which gives me positive 2.730075808. More spaces than you need. And number 9 is a law of sines, and number 10 is law of cosines problem. So, ABC, we're given A is 36.8 degrees. We don't know B, we don't know C. Given little a, 41.5 centimeters. Given B is 32.9 centimeters. And side C is unknown. So we first go for angle B. And angle B is the inverse sine of little b times the sine of angle A divided by angle A. And throw all those numbers in. Let's see. Inverse sine of B, 32.9 times the sine of 36.8 divided by 41.5, close inverse sine, and it says B is 28.35209624 degrees, which we record as 28.4 degrees. Then by subtraction, 180, subtract 36.8, subtract the answer I just got, and says angle C is 114.8479038, which we record as 114.8 degrees. But we use this value to compute side C, because side C is equal to side A times the sine of angle C divided by sine of angle A. So let's do that. A 41.5 times the sine of my answer,
Second answer.
divided by the sine of 36.8. And all that says is 62.9 centimeters. It says 62.865967997. 62.9 centimeters. Okay. And the last problem is the law of cosines. Given PQR, PQR, and we're given Q is 73.1 degrees, P is 15.4 inches, and R is 19.2 inches. First, we go for side Q. Side Q equals square root of P squared plus R squared minus 2PR times the cosine of Q. So throw those in the calculator. Let's see. 15, AC, square root. 15.4 squared plus 19.2 squared minus 2 times 15.4 times 19.2 times the cosine of 73.1, close cosine, close square root, and it says this is 20.8 inches. 20.83003482. We'll use this value to compute one of the others. And once again, don't forget, a week from Thursday is the final. So I'll just do side P since it's handy. Side P is equal to the inverse cosine of Q squared plus R squared minus P squared over 2QR. So throwing all that in there. Inverse cosine. Add an additional parenthesis. Q squared is my, oh man, and turn the thing off so I'm going to have to type some. 20, do this. I'm tired. So there's the entire course, no more one day.
It's 45 minutes.
Okay, 45.0? Okay.
And this
And if it's
subtracts
45.0, then from, this is whatever it is,
61.9.
61.9.
Yes, I got an A.
Ooh,
Helped you.
good job.
We're not here today.
That was
There's
test
four of
two.
them that